Yeah, welcome everyone to the webinar. Just want to say a quick word about our company GitGuardian before Mackenzie takes over and talks to you today about Docker security. So GitGuardian, we're a company based in Paris, France, founded in 2017. If you can go to the next slide, please. So we are exclusively, for the moment, very focused on secrets detection. And we have investors in the company who are GitHub co-founders as well as Docker co-founders, which is pretty relevant for today. We are based in Paris, but our customers are really around the world, including in the US and Japan. And we have two main products. So first of all is public monitoring. So here we're looking for credentials and other sensitive material on public repositories on github.com. We've realized that this is a place where there tends to be a lot of leaks of sensitive information. And so we have a unique method to help companies keep an eye on what might be appearing on public repos, including on the personal repositories of the developers. Our second solution is quite different, more focused more on the AppSec, DevSecOps side of things, where we're helping companies clean up their own internal systems. So especially their version control system, like their internal GitHub or GitLab or Bitbucket, and help clean up secrets that might be found within. What we call it is the problem of secret sprawl, where we know and we see from that all companies are having to deal with this problem where all kinds of credentials, API keys, database credentials, private keys are being found everywhere within their internal repos and other internal systems. So that's a quick introduction. I'll leave it to you, Mackenzie.
Thanks, Ramsey. Thanks for that explanation. So today I'm going to be talking about Docker security, in particular, securing your Docker images. And the webinar is really going to break up into two different parts. So at first, we're going to look at exploiting secrets in Docker images. So we'll run through quickly about what are secrets and what is Docker and how secrets end up inside Docker images, and a little bit about why this is a blind spot. And then we'll also use some real life case studies where secrets that were found in Docker images were actually used in a breach to exploit companies. And then we're going to run through a little bit of the findings that we've done inside Docker Hub. So as Ramsey just mentioned, GitGuardian scans public GitHub repositories. So we actually scan every public commit that's made to GitHub, about 5 million commits a day. But we also started scanning Docker Hub, which is kind of the public repository to store Docker images. And we'll share some of the findings of our preliminary research that we did, which we're trying to uncover the type of secrets and the frequency of secrets that are found inside Docker images. So first of all, just to get everyone on the same page, I want to quickly talk about secrets, particularly secrets inside software and what are secrets. So we have to understand that applications today are really no longer these standalone monolithics. They're built up of hundreds of different building blocks, and secrets are really what tie these building blocks together. So let's say that we're building an application, and this application is going to have lots of different components to it. So we start off by selecting what programming language we're going to use in this application. So let's say we're going to use Django. So immediately we have Django credentials that we need to deal with. Now, if we want our application to be able to take payments, then we're going to need some kind of payment processing system. So for instance, we may use Stripe. So we're going to need to integrate Stripe into our application. We're obviously going to need to have a database. So let's say we're going with a Mongo database. And again, we need credentials to be able to access this database. If we want to have a search function, perhaps instead of building it ourselves, we'll use Algolia. Again, we'll need to leverage credentials. Okta for authentication. And before you know it, our application begins to look like this collection of multiple different services, right? But it doesn't stop there, because we actually now need to host this application. So maybe we will host it on AWS. We're going to need to monitor what's happening. So we might integrate Datadog. We need to place to store our code and share this, so we have a GitHub account. We may need to do tests, so we have Circle CI to run CI/CD pipeline checks. And again, our infrastructure is now looking like a collection of all these services along with our application. Then we launch our application, and the marketing team want Salesforce integrations. We want to have Slack integration so that we can be alerted when the application is down or when new sales are made. We need to have Zendesk and Grafana dashboards to be able to see what's happening. So again, another collection of secrets that need to be used programmatically. And this doesn't even begin to include all of the private services that we may use internally, which again leverage secrets. So I like to use this slide to kind of really get an understanding of the scope of the problem when we're talking about secrets. We're not just talking about credential pairs that may access a service or a database. We're talking about a collection of hundreds and sometimes thousands of different services that we need to use programmatically. And we need to be very careful around, because all of these give access into our organization. They may give access to data, to customer information, to sensitive systems, to payment information, to banking. So there's a lot of different avenues an attacker can take, even if they gain access to just one of these services. So how do these secrets end up in Docker? Well, we see it in a couple of different ways, but when we're talking about source code and these secrets, because they're made to be used programmatically, essentially when these secrets end up in our source code repositories, then they immediately kind of through magic will sprawl through multiple different systems. So you can imagine when it enters into your Git repository, it will be sprawled or cloned onto multiple different machines. Maybe it ends up inside your messaging systems. And then it can also end up in your running applications. And this is really where Docker comes in, because when we build our application, we're going to take all that source code. And while there shouldn't be exposed secrets in there, if they are, then they will also end up inside that Docker image. And of course, we can then clone and back up all this information, including our images. So even if we clean out and have a fresh start, we can't be sure that these secrets aren't sprawled into multiple different projects, which again is kind of an attack vulnerability that someone may exploit. So let's talk quickly about Docker, just to get everyone on the same page. So what is Docker? So we can think of Docker as almost like a virtual machine. So with a virtual machine, we recreate an operating system and the hardware that runs it inside an operating system, that virtual machine. The problem with virtual machines is that they're really heavy. They use a lot of information, they use a lot of processing power, and they're not portable because there's so many different variables that go into it. And part of that is because it's also recreating that hardware, that virtual hardware component. So what Docker does, and some other container type technology, is it really simplifies and makes that virtual machine concept really portable. So it recreates the operating systems, but without recreating the hardware component. And the problem with virtual machines is that it recreates everything within that virtual environment, whereas Docker only picks and chooses the essential dependencies that your application needs to run. So the benefit of this is that it makes it much more portable. You can deploy it quickly, you can compile it quickly, and then you can run these Docker containers on multiple different systems. And it removes that element of incompatibility because everything's running in the same environment, but that environment is just a lot smaller. So hopefully that makes sense. But when we look into Docker a little bit more, we can break it up into three components. So we have our Docker file, we have our Docker image, and we have our Docker container. So the Docker file is really what we do to describe our image and our container. So this is code in itself, this Docker file. And what we're doing is we're describing all the different components that our application needs to run, the environment that we want to create. We're describing our application itself and the files that are going to go into this. So this is what our Docker file is. So really, this is what we do to build our Docker image. So our image is really our application and what it needs to run. So the image is really where we store all the crucial information. This is what we can pass around. This is what we share when we want to send someone over the application inside a Docker image. And the container is what is created when that image is running. So just to kind of give some clarity around the three different components. So the Docker file describes the image, and the image creates the container to run within. So these are the three areas of a Docker image. And this is kind of important to understand when we're talking about where secrets actually become exposed. So what I want to do now is I want to kind of explore what is a Docker image. So I have here open, this is a project called Dive. And what it lets us do is it lets us explore a Docker image. So here is a Docker image from GitGuardian called GG-Shield. And what we'll see is up here, we have the different layers of our Docker image. Now, this is essentially what our Docker file is, what it's describing. And we can move down through these different layers. And what you'll notice is that on the left, what's in green is all the files that have been added in these different layers. So as we go up or as we go down, we'll see different files that are being added into here. But this layer here is interesting because this is all the files that are our application. So this is the code. You'll see here we have a lot of Python files inside a folder called GG-Shield. So this is really what our application is. And obviously it's a Python application. So these are real code. So I like to illustrate this because Docker can kind of seem like this black box where we feel like it's this very broken down layer of kind of obscurity. But in actual fact, it's really just a file that contains a lot of code. And so my point being here is that if there are secrets within this code, then they're going to end up in your Docker image. So if I go back to the slides here, so what we'll see is we'll go through exactly kind of the different areas where secrets actually end up inside Docker images. So the number one place that we can find them is inside our code. So if you have hard-coded credentials within your source code and that gets pulled into your Docker images, then you're still going to have exposed secrets inside your Docker image. So just like we don't want secrets in our running applications, we definitely don't want secrets in our Docker images. And a common kind of proponent of this is if we have environment variable files and we make a mistake in how we configure our Docker images, and we accidentally grab all of those files and we put them inside the image, then we're going to have secrets inside our Docker file. So this is one way, and this is very similar to having secrets inside Git, and we can really treat this the same way. If we can make sure we don't have secrets inside our code repositories, inside our Git repositories, then we can go a long way in making sure that we don't get these secrets ending up inside our Docker images as well. So what about some other areas that are kind of more Docker specific that we can find secrets inside? Well, we actually find secrets inside our Docker file as well. So we talked about the Docker file, which is what describes our Docker image. So one thing that's quite common is we want to pass our Docker image to a repository host, a package manager or a package host. So I'll use the example of the Python version of this, so pip. Now this may be kind of the public version of pip, or it might be a private kind of package host that you have. So what we can do is we can put our credentials for this private package manager in our Docker file. And we actually see this quite a lot. But unfortunately, what this means is that these credentials are now in our Docker image. And if we go through the different layers, like what we just talked about, we will actually find these credentials and we'll be able to exploit them. And then we'll be able to access this private package manager. And you may be wondering, why is that such an issue? Well, this is a huge problem, because if we have access to this private package host, then we can actually update packages in there with malicious code. So we can turn a Docker image malicious, send it to the host, and then we can sprawl our attack from there. So really quite an important way that we really don't end up with these credentials inside our Docker files. Now, the next area that we actually found in our research, which was quite an interesting, that we saw a fair bit, which was really interesting. Now, one of the reasons why this was so interesting is because it showed a little bit of a misunderstanding in how Docker really works. So I'm going to go back to the point that I've touched on a little bit, that these Docker images are made up in layers that are described in the Docker file. You can think of it a little bit like history, like there's a history of everything that you do within your Docker file. So here we have a similar example to what's happening before. We have a file called .netrc, and within this file, we have credentials for our pip repository again. So rather than putting them hard-coded in our Docker file, we have them in this netrc file. We're adding this into the Docker image. Then we're going to pass these to our package manager. And then because we know we don't want this file in our Docker image, this last line down here, what we actually do is we remove this. But again, Docker images are created up in layers, which means that in our final layer, we may not have this netrc file that contains credentials, but in previous layers, it's still there. So when we download that Docker image, we can still extract these credentials. I like to think of this a little bit like Git history, where if you commit the hard-coded secret and then you delete it and commit again, that secret is still in your Git history. And this can be transferred over into Docker. If you add credentials into your Docker file through a file and you remove that, it's still there in the layers of the Docker file. So these are kind of the three main areas that we have really discovered secrets inside Docker images. So hard-coding secrets into your source code, and then having specific secrets, namely to private package hosts in Docker files. So what I want to do now is I want to really run through a real-world example that we can discuss where secrets have actually been found inside a Docker image and were exploited in a real life breach. So earlier in this year, in 2021, we heard that CodeCov, a very popular code coverage tool, was actually breached by attackers. And as we went on, we discovered that this was really quite a severe attack. And later on, we started hearing from massive companies like Rapid7, Monday.com, Twilio, and even HashiCorp disclosed that they were affected from this breach. So let's talk a little bit about what happened and what Docker was kind of had to do with this. So CodeCov is a code coverage tool. And essentially what it does is it checks how much of your application is being tested through your CI pipeline. So you want to kind of get as close to 100% coverage in your testing as possible. And so CodeCov helps you get visibility over this. So it's quite a simple tool. It's very powerful. It's a great product. And used by a lot of people, about 20,000 customers at the time of the breach. So if we look at the process that we would go through in a deployment, we create our code, we commit it, and then we send this into our CI pipeline, which kind of builds our application, it tests it, it reports back on it. So this is the area where CodeCov was, in this testing phase within our CI environment. And then obviously once that passes, we get to our deployment pipeline and we go through the process to deploy our application. But in the CI environment, we have a lot of secrets. Now, they may not be secrets to our production, and hopefully they aren't, but they can still be secrets to private package repositories, and really importantly, our private Git repositories. So our CI environment has access to our code, even if it's private. So what these attackers did was they actually compromised code.cov by sending all these secrets that were our environment variables to the attacker. So how did they do this? Well, at first, they discovered that code.cov in their Docker image was misconfigured and contained a secret to code.cov's private code repositories. So code.cov had a misconfigured Docker image, and this was the same Docker image that anyone could download and use to kind of run the application of code.cov. Hidden within this Docker image was a credential to code.cov's code repository. Now, from that, the attackers were actually able to insert a malicious line of code into code.cov's application. They did it into a bash uploader script, and because they were correctly authenticated into the Git repository, it didn't raise any alarms that this is actually an attacker inserting this code. And in the file that they did it, bash uploader script, it was kind of a very kind of difficult file to really discover malicious activity. And so once that was done, code.cov then turned malicious, which means all the applications that were running this version of code.cov, so again, they had 20,000 customers, including massive companies, were having their environment variables sent back to the attacker. And then that attacker was able to access the private Git repositories of all those companies. So Rapid7, Twilio, Monday.com, they all had to report that their source code, their private source code, had been accessed by a malicious third party. So all of this stemmed from the fact that code.cov had a misconfigured Docker image that contained a secret. This was a public image that anyone could have downloaded and anyone could have found. So if a sophisticated company like code.cov, because really they are a great product and a great company, it makes you wonder how many other Docker images are out there that kind of contain this malicious code. And we actually can provide somewhat of an answer to that. So we scanned Docker Hub. So Docker Hub is the public-facing repository for all Docker images. You can think of it like public GitHub, but for Docker images. And so we started scanning public Docker images on Docker Hub to see how many of them contained secrets. And what we found is that 7% of all Docker images on Docker Hub contained some secrets in them. So this is really quite an alarming rate. It's actually very similar to the number that we find within public Git repositories. In fact, it's a little bit higher. So what I thought I would do is we're still running through this research project, so I only really have preliminary results here, but I think they're still quite interesting. So the methodology that we took in this research was we actually scanned 2 terabytes of Docker images, so a really huge amount of data to start with. And we scanned all of those images for any kind of secrets. And you'll see here on my screen, we have two kind of categories here. So we have the percentage of secrets that we found inside public Docker images. And then I also compare that just as a comparison to the amount of secrets that we find in public Git repositories. So as Ramsey mentioned at the start, and I kind of touched on, GitGuardian scans all public repositories, all public commits made to GitHub for secrets, so about 5 million commits a day. And when we find a secret, we alert the developer responsible, but we also have this information of kind of the type of secrets that we found. So what we'll notice is that if we scroll down, the numbers in the Docker images are considerably left for what we can call named products. So cloud providers, version control platforms, messaging systems. If we go back to really one of those first slides that I had that showed all of the secrets together, all those different services, we actually found considerably less of them inside Docker images. But what we found a whole lot more of is these private keys. So 22% of secrets that we found in Docker images were private keys. And we compare that to 2 or nearly 3% that we found in Git repositories. So these private keys actually gave access to what we were talking about before, these package management systems, or more related to the infrastructure of an application, and were more kind of internal tooling systems. Now, this isn't really better or worse than the other areas, but it shows that it's actually a totally different area of secrets that we're finding in these Docker images. It's really granting potential attackers access to the inner working infrastructure of your application. And this can be really quite scary because, as we saw in the code.cov example, when we give access to these infrastructure, then attackers can actually squat inside these systems undetected and inject malicious segments of code, malicious applications, or really kind of monitor activity that's happening. So this can be hugely problematic for an attacker that really wants to move into these different areas of your application and cause a lot of damage. So very interesting results that we have here. And as I said, again, they're slightly different from the results that we see inside those public Git repositories. So how do we actually scan these Docker images? Well, this is something that everyone can do. We have an open source tool called GGShield, and it works with the GitGuardian secrets detection engine. And you can scan, you can set up GGShield to be a pre-commit hook, so your developers can get an alert before they commit a secret, but they can also scan Docker images. So it's very simple to do. Just run the command GGShield scan Docker, and then obviously the company and the Docker name. And this will scan everything within that Docker image, including the different layers that we talked about in the Docker file, all the activity that's in, all the code and activity that's in the Docker image as well. And if it finds anything, then it will send you an alert. Now, what's really cool is that because this is a CLI tool, we can actually use this in our CI/CD pipeline. So we can immediately scan Docker images after we create them. And if they contain secrets, reject them and then not send them to our package managers. So quite a powerful tool to be able to help prevent and kind of gain visibility inside these Docker images, which can be a little bit of a mysterious black box. So yeah, again, so GGShield, it uses the GitGuardian secrets detection engine through API. So you guys can test this out today. It's a great lot of fun and can be really quite powerful in protecting. Now, I'm almost at the end of the webinar, but I always like to kind of provide some additional information and additional reading. So I wanted to talk about protecting Docker images a little bit beyond just secrets here. Docker seems to be a little bit of a blind spot for organizations. There's a number of ways that attackers can really kind of exploit these Docker images. And it's becoming a more common thread that we're seeing Docker images as an entry point, as that initial access point in a sophisticated attack. So on our blog at blog.gitguardian.com, hopefully we can share this with you along with this webinar. We actually have kind of an in-depth article, but also a cheat sheet that's very easy to pass around that explains some of the common security elements that we see inside Docker images and what we can do to harden and strengthen these Docker images. So of course, we talk a little bit about secret scanning in here, but we also talk about the misconfigurations and other areas that we can do inside our Docker images. So if you're interested in being able to really secure your Docker images, then this is a great resource that we can share with everyone. It's totally free, and you can pass around to your developers and employees to help them kind of understand what we can do together to really help secure this otherwise potential blind spot in our organizations that is Docker. Thank you.